Hi guys, so today I want to go through the second set of notes from our Unit 4b. If you guys look, our Unit 4b, we're in Big Idea 4b, Solution Stoichiometry, and we're going to go over the notes on making a solution. Okay, so if you want to click on that, open up widescreen for that. Okay, so I want to go through how we can make a solution in an actual lab. Okay, so I have a few examples for us to use. Okay, so a few examples of what we're going to be doing. The first one says, determine the molarity of a 250 milliliter solution containing 4.5 grams of sodium chloride. Okay, so the important things we need to pull from that are that we have 4.5 grams of sodium chloride, we're looking for a 250 milliliter solution, and we're trying to find our molarity. Okay, so first off, one thing I know is that our molarity is equal to the moles per liter of solution. Okay, so moles per liter of solution, that's what our molarity is. Okay, so we have grams and we have milliliters. So I know that we know how to go from grams to moles, and we know how to go from milliliters to liters. Okay, so just by doing two simple conversions, we're able to get into our formula and be able to set it up correctly. So we know that we have 250 milliliters of solution. Quick conversion, we know that there are 1,000 milliliters in every 1 liter. Okay, so that gives us 0.250 liters. Okay, and that's because our milliliters will cancel out and all we'll be left with is liters. Next, we have 4.5 grams of sodium chloride. We need to use molar mass to convert from grams to moles. Okay, so we need to use the molar mass of sodium chloride. The molar mass of sodium chloride is 58.44 grams per mole. Okay, so if we want to put that in, we make our T-chart. We have 58.44 grams of sodium chloride in every 1 mole NaCl. Okay, we solve for that. We end up getting 0.077 moles. Okay, and so now we can stick it right into our equation. Okay, so way over here, we have our molarity is equal to moles divided by liters. So we can put our moles, 0.077 moles, divided by our liters, which is 0.250 liters. We got this from here. We got this from here. So now all we have to do is plug that into our calculator and solve for that, and we get 0.308 molarity. If we want to look back to our original equation, we need to have 2 sig figs, okay, because that's our least number of sig figs in the numbers that are given to us. Okay, so it's going to be 0.31 molarity. Okay, so just like that, we're able to solve for moles, we're able to convert our milliliters to liters, and then we're able to put it into our equation and solve for molarity pretty easily. Okay, now we have for number 2, it says how many liters of solution are needed to make a 2.00 molar solution containing 7.5 grams of NaOH. Okay, so what we are given, we're looking for liters. We have a 2 molar solution, and we have 7.5 grams of NaOH. Alright, so one thing that you guys need to learn is that 2.00 molarity is the same thing as 2.00 moles over 1 liter. That means that we can use it as a conversion for these problems. So we can use molarity as a conversion between moles and liters. Okay, so that's very important. Whenever you see molarity, you should be thinking you can use it as a conversion. Okay, so we start off with the grams that are given to us, 7.5 grams of NaOH. We need to convert that into moles. So we can go from grams to moles. Okay, so with that, we can use our molar mass of NaOH. We know that there are 40 grams of NaOH in every 1 mole of NaOH. Okay, so just like that, our grams of NaOH cancel out, and now we have our unit in moles. Okay, so now we can go from moles to liters using our molarity, our molarity conversion factor. So that says we have 2.00 moles for every 1 liter. Okay, so now our moles of NaOH cancel out, and we're left with our unit in liters. Okay, so if you solve for that, you should end up getting 0.09375. Okay, if we want to have that in the correct sig figs, which is 3 sig figs, we need to have 0.938 liters. Okay, so now an important thing for these, we have a few different types of conversion factors now. We have our moles, which is in the middle. We have a way to convert between there and grams. Okay, and that's our molar mass. We have a way to convert between there and particles or atoms. And that's our Avogadro's number. We have a way to convert between there and liters of gas at STP, and that's our 22.4 liters per mole. Okay, and now our most recent conversion factor is molarity. Okay, so molarity lets you convert it between moles and liters. So this is a second way to convert between liters. Now the difference between this one and this one is that this is moles of a or liters of a gas at STP. This is liters of solution. Okay, so in this unit, we are going to be mainly using liters of solution. So you're going to get used to using molarity as a conversion factor to convert between moles and liters. This is very important. Okay, so let's go back to doing our equations. So we just have 2 more quick to get through. Number 3, it says determine the molarity of a 1.5 liter solution containing 12 grams of potassium iodide. So we have 12 grams of potassium iodide, we have a 1.5 liter solution, and we are trying to determine the molarity. So we know that molarity is equal to moles over liters. Whenever you're trying to determine molarity, make sure you know this equation. Whenever you're trying to determine molarity, every single time. Okay, so we don't have moles, we have grams, but we know how to get that into moles. And we have liters. So, given 12 grams of Ki, we know that the molar mass of potassium iodide is 166 grams of Ki per mole. Okay, so we can solve for that. Our grams of Ki cancel out, and we end up with 0.072 moles. Okay, so now we have moles and we have liters. So we can put that right into our equation. Equals 0.072 moles over 1.5 liters. If you plug that in and solve, you should end up with 0.04819 or 0.048 molarity, okay, if you put it in sig figs. Okay, so 0.048 molarity is our final answer for that. These are pretty quick, they're not too tough. And our last one, how many grams of NaCl are needed to make 0.75 liters of a 5 molar solution? Okay, so again, whenever you see molarity in a problem, you can think of it as a conversion factor. That's the same thing as 5.00 moles over 1 liter. Okay, so you start off by giving the number that's given to you, and that's not your conversion factor. So you want to write down 0.750 liters of NaCl. Now we can convert that into moles using our new conversion factor. Okay, and our new conversion factor is over here. Okay, so we can convert that doing that. We have 5.00 moles for every 1 liter. Okay, so that's our first conversion factor. That'll cancel out liters of our NaCl. Now we know we can go from moles to grams using our molar mass. So this is in moles of NaCl. And we know the molar mass of NaCl is 58.44 grams of NaCl for every 1 mole of NaCl. So just like that, our moles of NaCl cancel out, and we're left with 219.15 or 219 grams of NaCl. So just like that, we were able to convert from liters to moles using our molarity as our conversion factor, and then from moles to grams using our molar mass as our conversion factor. So one thing that you guys might want to write down that's kind of new to you, okay, you guys might want to write down this. Okay, so we know that our moles are still in the middle, our moles are in the middle. We can go to liters using our molarity. And so that's the same thing as moles per liter. And it's always going to give you a certain molarity. So this is a very important part right here. This is our new section on there. Okay. Okay, if you guys have any questions, please let me know. These are your practice problems for today.